Hello students, so we are continuing with our second chapter. Yes, so we have already done one part of this chapter in our previous class. Okay, so before going into today's class, we would like to first recap some of the things. Okay, so in our previous classes we just did an introductory class, and what we did, and in that class we learned that most of the substances or most of the matter around us is not pure substance. Yes, so most of the substances or most of the matters are made up of what? Mixture of substances. Yes, so we took the example of air. Yes, we took the example of milk. So air is a mixture of gas. Okay, so most of the things that we look around us, most of those things are not pure substance. Okay, not a single pure substance, most of them are mixtures. Okay, so that is why the chapter is named as Is Matter Around Us Pure? Okay, so in that class itself we have seen that how mixtures can be classified. So we saw mixtures can be classified into two types, that is homogeneous mixture and heterogeneous mixtures. Okay, and homogeneous mixture, what we saw, that their composition remains same throughout the mixture. Okay, and in heterogeneous mixture we said that their composition varies. Okay, and we also saw the differences between homogeneous and heterogeneous mixtures, and we also noted down. Yes, we made tables and we saw the differences between homogeneous and heterogeneous mixture. Again, in the same class we also saw that how mixtures can again be categorized into four types. Yes, what were those? Those were, one was solution. Yes, then colloids. Yes, then emulsions. Yes, again what we saw? Again we saw what? Those were suspensions. Yes, so these are the four types of mixtures. So today we will be looking at the first one, that is solution. Okay, so generally this term solution is very common to us. Yes, because every time now and then we listen this word. Okay, the solution of this thing, solution of that thing. Yes, we listen. So what is solution? Okay, so first we will be going at what actually solution is. So what is solution? Solution is a homogeneous mixture. Okay, so first criteria that a mixture has to satisfy, that is for a mixture, so if we will tell that if we say that a mixture is a solution, then the first thing we have to see that whether that mixture is homogeneous or not. Okay, so the first thing while determining that a mixture is a solution is that it should be homogeneous. Okay, so if it is homogeneous, then we will see that its composition will be same throughout the mixture, or it will be constant throughout the mixture. Okay, so therefore solutions can be simply defined as solutions are homogeneous mixtures. It can be two components or more than two components also, but the important thing is its composition should remain same throughout the mixture. Okay, so let us take two examples. That is, one is lemonade. What is lemonade? That is when we mix lemon juice in water, the common name it is given to, informal name is lemonade. Okay, and the other is a salt solution. Okay, that means we have dissolved salt in water. So we got two types of mixture. Okay, so if we say that these two mixtures that we considered are solution, then the first thing they should satisfy is that both of them should be homogeneous. Yes, and if we look at both these two mixtures, we see that these are homogeneous. Why we can say it is homogeneous? Because we are not getting any separate layer. Okay, we are not getting any separate layer, one for lemon juice or one for water. We are not looking on that. Yes, so we are not getting separate layers. So in heterogeneous mixtures we get separate layers of the substituents. Yes, of the constituents. Yes, that means the substances that are making those mixtures will get separate layers. For example, in salt solution, what we saw, that when we put sand in water, we will see that sand will settle at the bottom of the vessel and water will be floating, or it will be present above the sand. Okay, so that means you can see a distinct layer of sand at the bottom of the vessel. Yes, so but here in the lemonade or the salt solution, we will see that its composition is same throughout the mixture. So if you will take one sip from the bottom, or if you take one sip or one drop from the top of the lemonade, that is the mixture of lemon juice in water, the taste is same. So why the taste is same? Because its composition is same. Okay, so similarly in salt water also we will see that the taste of a small portion of the solution from the top or at the bottom or at any part of that mixture, you will see that the taste is same. So why the taste is same? That because the, what you can say, their composition remains same. Yes, so therefore these two are good examples of solution. Okay, so now every solution has two parts. Okay, so what are the two parts? One is solvent and the other is solute. Okay, so every solution has two part. One will be, two part means two components. One is solvent, other is solute. So how we can determine which one is solvent and which one is solute? So what we see, that if we see a solution, suppose we are taking the example of salt solution. Okay, so what we are doing, we are dissolving salt in water. Okay, so that means the component in which we dissolve the other component, that component will be known as solvent. That means here we are dissolving salt in water, therefore we will say that water is the solvent. Yes, so in case of the lemonade, what we are doing, we are adding lemon juice to the water. Yes, so water will be the solvent. Okay, so that means what we will see, if the substance in which we are dissolving another substance, so that substance is known as solvent. Okay, and always we will see that the amount of solvent in a solution will be more. So for example, in the salt solution, what do you see, that amount of water should be more and amount of salt is less. So since the amount of water is more, we are terming it, we are saying it, or we can easily determine that water is the solvent. Okay, now what is solute? The solute is those substance which is added to the solvent. Okay, so suppose in salt solution we are adding water to we are adding salt into water, so here salt is the solute. So in case of that lemonade, that is, there we are adding lemon juice into water, therefore there lemon juice is the solute. Okay, and the quantity of solute is always less. Okay, so for example, if you take the salt water, you will see that the amount of salt will always be less than the amount of water. Yes, so these are the two components of solution. One is solvent, one is solute. The amount of solvent is always greater than the amount of solute. Okay, so now you will see that mostly when you say solution, okay, or you heard the term solution, you will always imagine that it will be a liquid. Yes, so whenever I say solution, we generally think that it will be liquid. Yes, that is something is dissolved into liquid. Yes, but this is not always true. Okay, it is common that generally we see that most of the solutions are existing as liquid. Okay, but this is not always true, that solution can be gaseous, solution can be liquid, and solution can be solid as well. Okay, so generally it is seen that most of the people, they think that solution will only be present in its liquid state. Okay, but the physical state of solution, okay, so how solution will be solid or solution will be liquid or solution will be gaseous, it can be determined by the physical state of solvent. Okay, so in this table, if you look at the table carefully, you will see that this column is of solvent and this is of solute. Okay, and you see that here the type of the solution is gaseous solution. So for here you are seeing that for gaseous solution, the physical state of the solution will be gaseous. Clear? Very obvious thing this is. Yes. So you see that in gaseous solution, the solvent used will be also gaseous. Okay. So if the solvent will be gas, then the solution will be gaseous. So similarly, if you see, if the solvent is liquid, then the solution will also be liquid, and if the solvent is solid, then the solution will be solid. So who is determining the physical state of solution? The physical state of solvent will determine the physical state of solution. That is, the type of solution will be determined by the physical state of solvent. Okay. So you cannot simply say that always solution will be liquid, because it will be determined by the physical state of solvent. So here I am also giving you the examples of different types of solution. So in the first type of solution we are considering is gaseous solution, and here you see that in gaseous solution, for all the three different types of gaseous solution, the solvent will be gas. So the solute can be gas, it can be liquid, it can be solid. Okay, so for gaseous solution, solute can be anything. It can be gas, it can be liquid, it can be solid, but the solvent will be always. So if you look at gaseous solution, you will see that all the solvents are gases, and solute in for first case you can consider that if the solute is gas, so then also you will get a gaseous solution. And an example is that mixture of oxygen and nitrogen gas. Similarly, if you consider that if the solute is a liquid, and solvent will be for a gaseous solution always gas. So for example for that is chloroform. Okay, so chloroform, if when it is mixed with nitrogen gas, so chloroform is a liquid and nitrogen gas is a gas. So since solvent is a gas, so therefore the solution will be a gaseous solution. Okay, so instead of chloroform, sometimes you can also see if you can make very small droplets of water. Okay, and if you can mix that droplets of water into any gas or in air, okay, so then also you will say that it will form a homogeneous mixture. Okay, and that can also be an example of gaseous solution. Okay, so similarly solid, if the solute is solid, then also you may get a gaseous solution. The only criteria is that the solvent should be gas. So here the example is camphor. So what is camphor? So camphor means it is very commonly found in the kitchens. Okay, so what is camphor? In Assamese or in Hindi also, camphor means karpur. Okay, so a white color substance which you get a nice fragrance from those. Yes, it is commonly known as karpur. Yes, white solid substance. So that means those solid substance undergo the process of sublimation. So, and during that also you will see that small very small tiny particles of those solid camphor, it is mixed with air. Okay, so in this case, if that camphor is mixed with nitrogen gas, then also you will get a gaseous solution. Okay, now the most common type of solution, that is liquid solution. So for liquid solution, the only thing you have to know that the solvent must be a liquid. Okay, and solute can be anything, solid, liquid or gas. So if the solute is gas, so then we can see that if oxygen is dissolved into water or carbon dioxide dissolved into water. Okay, so all type of such solution where a gas will be dissolved into a liquid will be a liquid solution. Okay, again if the solute is also a liquid, for example the example that we have already considered that lemonade. So what is lemonade? That is a solution of lemon juice in water. Okay, so that also the lemon juice is solute and it is liquid and it is dissolved in water, so the solvent is also liquid. So it is an example of liquid solution. Okay, in this case also in example it is considered that ethanol is dissolved in water. So ethanol itself is liquid and water is the solvent which is also liquid, and it will give a liquid solution. So similarly, if you dissolve salt, if you dissolve sugar, or if you suppose dissolve glucose, for example, you can easily buy those Glucon-D packets or Glucose-D packets. Okay, so very commonly available brands of glucose powder, glucose supplements. Yes, so if those glucose powder you dissolve in water, you get a solution of glucose. in water. Yes, so that means those glucose powders are solid and you are dissolving that in a liquid solvent, and that liquid solvent is water, and you are getting a liquid solution. Okay, so the important thing is that you have to understand which one is the solvent and which one is the solute. So whenever any type of solution is given to you, and then the first thing you have to identify that which one is the solvent and which one is the solute. Okay, so once you identify the solute and the solvent, then the questions become very easy for you to solve. Okay, and you must try to remember an example of each type of solution. Okay, so you have to know the examples of different types of solution, because sometimes in question generally is asked that define a type of solution and give an example. Okay, so in everything that you learn in science or in this chapter, you have to remember at least one example of all those particular topics. Okay, next we are going to solid solutions. Okay, so solid solutions are very rare. Okay, so first thing you have to remember that in solid solution the solvent will be always solid and the solute can be anything, gas, liquid or solid. So if you it is hard to imagine, but what happens that some metals, they have very small tiny pores, okay, in their structure, and in those tiny pores or in those tiny holes, what we can do, we can insert some gaseous molecules. Okay, gaseous molecule like carbon dioxide or hydrogen. In this example we have taken hydrogen gas as the solute, and palladium is a metal, and that metal we are using as solvent. So palladium metal has some tiny holes. Okay, so in these holes we can insert hydrogen molecule. Okay, so then we will get a solution of hydrogen gas in palladium metal solvent. Okay, so that is an example of solid solution. Okay, next we are using a liquid solute in a solid solvent. So for example, we are considering a metal, there is sodium. Okay, sodium is a metal, and if we are making a solution of mercury and sodium, so that type of, when mercury is mixed with sodium or mercury is mixed with zinc, that type of things are known as amalgam. Okay, so when you are using when you are preparing an amalgam of mercury with sodium, that means the sodium metal is the solvent. Okay, so sodium is solid and that is metal and that is the solvent, and mercury is the only metal which exists as liquid. Okay, so this is very important for you to know that mercury is the only metal that exists as liquid. Okay, so in this case we are taking mercury as the liquid and liquid solvent. Mercury is the liquid solvent, mercury is the liquid solute, and the sodium metal is the solid solvent. Okay, and now a solid solution where the solute is also solid. So if copper is dissolved in gold, okay, so that means in gold and copper is mixed, so it will give copper and gold both are solid, and if both of these metals are mixed together and if a solution is prepared, so that is a solid solution where solute and solvent both are solid. Okay, again one good examples of solid solution are alloy. Okay, so now what is alloy? Yes, so we have to look at this. So alloys are the mixtures of two or more metals or a metal or a non-metal. That means alloys are mixture. Okay, so how alloy is prepared? So alloy is a mixture where one component must be a metal, okay, and the other component can be a metal or it can be a non-metal. That is, an alloy can be a mixture of two metals, or alloy can be a mixture of one metal and non-metals. Okay, so and the most important thing is that they are components of an alloy. That means the substances that are together making an alloy, it cannot be physically separated. You cannot separate it easily. Okay, so therefore mostly you will see that the composition of the components of an alloy remains same. Okay, so and it is a homogeneous mixture. Why homogeneous mixture? Because you cannot physically separate it. So when you studied homogeneous mixture, I think you have noted it that a property of homogeneous solution is that the homogeneous solution cannot be physically separated easily. Okay, cannot be separated easily by using physical method. So alloys also, the components of alloys also cannot be separated easily using physical method. Okay, but one thing we have to note that some alloys also it is seen that in case of some alloys the composition is not constant all throughout the mixture. Okay, so therefore you will see that in some books or in some cases you will see that alloy is not considered as a proper solution, it is mostly termed as a mixture. Okay, why mixture? Because in some alloys the composition is not constant or not same throughout the mixture. Okay, and here we were discussing some common examples of alloy. This is the table. Okay, and you see the first alloy is bronze. Okay, so we are all familiar with bronze. Yes, so bronze medal, silver medal, gold medal, yes, very common thing. So we all know, we all have heard about bronze. So what is bronze? Bronze is a alloy of copper and tin. That means it is a mixture of copper and tin, both are metals. Yes, so in this case which one is the solvent? Copper is the solvent because it is present in more quantity. There is 90% of bronze is copper and 10% is tin. Okay, and where it is used? It is mainly used to build statues. Okay, making medal, sword, artistic materials. Okay, so you have to also understand, know the uses also. Okay, the other is brass. Okay, so what is brass? Brass is the alloy of copper and zinc. 70% copper, 30% zinc. Again steel. Okay, so steel is the mixture of iron and carbon. Okay, and stainless steel is the mixture of iron, carbon and chromium. Okay, and sometimes nickel is also used in making stainless steel. Okay, so why stainless steel? Stainless steel does not rust. Okay, so it is a very important property of stainless steel, that it do not rust easily, and that is why the stainless steel is mainly used nowadays. Okay, so in place of iron you will see that nowadays more use of stainless steel is taking place. Okay, this is because they last longer, because they are not rusted easily. Okay, so you will see that here the composition is also mentioned. Because why composition is mentioned? Because only at those, because to make steel you have to add accurately 99% of iron and 1% of carbon. Okay, so that means their composition cannot vary, and therefore I am saying that most of the alloys are solid solution. Why? Because they have a same composition all throughout, that is their composition is fixed. Okay, and we know that if for any kind of mixture, if their composition is fixed, then those are homogeneous mixture. Okay, so therefore we will see that most of the alloys are homogeneous mixture or solid solution. Okay, so the another important is duralium. Okay, so this pewter you do not need that much, but the other examples, that is bronze, brass, steel, stainless steel, duralium. Okay, so these are important. Okay, so these are some example of alloys. Okay, so with this we know that we have learned about the types of solution, how the physical state of solvent determines the physical state of solution. So what are different type of liquid solution, solid solution, gaseous solution, what are solute, what are solvent. Okay, what is the solution, what are alloy, what are examples of alloy, all these things we have learned. Okay, so in this particular chapter the most important thing is that we have to understand the properties of different types of mixture. Okay, so properties of homogeneous mixture, heterogeneous mixture, how we can identify which is homogeneous, which is heterogeneous, all these things we have to understand. Okay, and in between the chapter we will get some numerical things also, that how we can express the concentration of different components of a solution, that we will be looking at our, or will be learning at our next class. That is how the solution of different components in a solution, how different components of the solution have different concentration. Yes, and how we can express those concentration. Okay, so there are some particular terms to express the concentration of components of a solution. Okay, so that we will be looking, or we will be learning it in the next class. Okay, so today I think we'll be ending here. Yes, so please revise all the things on the type of because it is very important to be to clear a concept, okay, at the beginning of the chapter itself. That is, you have to know from the first day itself that what are homogeneous mixture, what are heterogeneous mixture. All these things, the concept about all these things must be clear. Okay, so what is solution, what is solvent, what is solute, only then you will be able to solve the numerical problem. Okay, because when you will be using some mathematical formulas to express the concentration of different components of a solution, then the question will be such that if your concept about solute and solvent is not clear, or a concept about solution is not clear, you are bound to face some difficulties. Okay, so there will be a confusion. So for that, please revise these two classes that we have learned. Okay, so those things that we have learned. Okay, and for alloy, you need not make that much attention, just you have to know what is the definition of an alloy. Okay, so why it is said a mixture, okay, and some examples of alloy, okay, with their composition, because in alloy, for making an alloy, their composition is very much necessary. Okay, so whenever you give an example of an alloy, you have to also know the composition of the different metals or different metals and non-metals that is used in making that particular alloy. Okay, so this is all about today's class. Okay, in next class, I have already told, we will be proceeding more into the chapter, going more deeper into the chapter. Okay, so at this point of time, I am again making the same request. You already know the name of my channel. Yes, so please subscribe my channel to get more videos on your subject matter. Okay, so thank you.